In this video, we are going to focus on esters and how esters are formed through a chemical reaction called esterification. So esters play an important part in characteristic aromas and flavors, right? Aroma has to do with smell, right? So let's get our pen and let's go purple, right? So nice esters smell beautiful, and sometimes they smell pretty disgusting. But esters are responsible for a lot of our very fragrant compounds. So marigolds, raspberries, and bananas all contain esters. A lot of the fruity scents are esters. So this is what an ester looks like, our functional group, right? We've got that carbonyl group, and we're also going to we have that carbon chain, and now we have a carbon chain. So notice it looks very similar to our organic acid, but instead of, there's no H here, the H, right? We lose the H and we attach an R, another carbon group, and then this is going to come from an alcohol. So an ester really derives from a reaction between acids and alcohols. So our reaction between an acid and an alcohol is going to give us this new functional group called the ester. So this is the ester functional group right there in the middle. And so this is our, right? This is our code, right? So sometimes I get this weird line, not sure why. All right, so there's our little letter code, COO, right? And then R and R prime. Remember, R prime can be the same as R, or it can be different than R, but both just mean separate alkyl chains, right? Hydrocarbon chains, right? There's our organic functional group and our code. So we have a double bonded oxygen, and then we have a single bonded oxygen, and now we have this as an interior carbon. Whereas the acid functional group is at the end of the carbon. So now let's look at how we're going to name esters. I'm sorry, I forgot to mention what page we were on. That was page number 71, and now we're on page number 72. All right, so how are we going to name this thing? So the first thing that we're going to do is we're going to name the alkyl chain attached to the oxygen first. So where is the alkyl chain attached to the oxygen? Right there. So we're going to name that first. And again, you should have table R open so that you can see, how does table R name a compound? How am I naming the compound in your notes, right? Then you're always using your analytical skills to mimic and transfer, figure out the puzzle. So whenever we name anything at any alkyls, we're counting the number of carbons. So how many carbons are there? So that's 2. So now we're going to name the alkane chain that the oxygen double bond is attached to, and we're going to drop the E and add OATE, right? Because the ending is OATE, and that is going to indicate an ester. So that's our carbon chain that we're going to count, and in this one, there are 3 carbons. In that chain, there's 2 carbons in this chain. So now notice that says YL. So we are going to use a YL here, and we're going to have an ending of OATE here. So then when we name this, and I know it's right in your notes, but I'm going to name it for you. This is F because there's 2 carbons. And since it's a branch off of this oxygen, we use YL. So now I have ethyl. And now I do this part. I count the number of carbons there. So that is prop. And so I've got the basis of propane, drop the E, and I'm going to add that OATE. And I put them together. I named this part first, ethyl, and this part second, propanoate. Ethyl propanoate. Now let's look at the condensed structural formula, right? So I have a CH3, a CH2. Now I have a C, and I have an O, right? That's COO, and now I have a CH2 and a CH3. Here's my letter code combination for ester, COO. Okay, and let me move this over here. Here's that, here's that COO letter combination. And then there we have that there. So sometimes you'll see it like this. There's that COO. Okay, so let's give this one a name. All right, so I'm mimicking what I see on table R. I'm going to name the branch first. So the branch comes after that oxygen. So the branch comes after here. So count the carbons, 1, 2, 3. So then this part of the molecule is a 3-carbon branch. So then 3 carbons is prop, and then YL branch. So then this is now going to be propyl. And now I named this part, right? So that I count the carbons, 1, 2. So then this is F, and then we drop the E, right? Ethane, drop the E, and add the ending OATE. So this is the ethanoate part, and that's the propyl part. Now we put those two things together, and we have propyl ethanoate. Propyl ethanoate. And sometimes that's going to be called acetate, but we're just going to ignore that. Or you can call this propyl acetate. Okay, so let's give this one a name. All right, remember, I named the branch after the oxygen first. 1 carbon. So this is methyl. The esters are probably the hardest ones to name. Now I'm going to do this part, count the carbons, 1, 2. So then this is like ethane, drop the E, add OATE. Now put them together, the branch first with the ethanoate. Now I have methyl ethanoate. Or you could say methyl acetate, but again, we're not going to focus on that. Now we're going to draw one. We're going to draw ethyl acetate. So remember, the acetate, I'm just going to have to change that. Let's go back just a sec. And we're going to draw the ethyl acetate. So then here is our ethyl, and there's the acetate. I don't like this one, so I'm going to draw a different one. Methyl propanoate. So then this YL is going to talk about the branch, right? So, and I'm going to make sure I'm mimicking what I see on table R. So on table R, they named something with the branch over here, right? Because that's where the branch is. And now I'm going to have, this is my carbon chain, propanoate. So I know that I have a 3-carbon chain. So then I am going to do my 3-carbon chain. I'll just do it over here. So 1, 2, 3-carbon chain. And now I'm going to draw that ester functional group, right, which is this part right here. C double bond O, O. And now there's that branch, methyl, 1 carbon. All right, so there's my skeleton structure. Now my last bit is always to make sure that every carbon has 4 bonds around it. Now that one still needs 2. This carbon's all set with its 4. Oxygen is all set with its 2. And then that carbon needs that. And at the end of all of these lines are H's. Okay. There we have our methyl, right? That's this part. And then our propanoate. So now, given this ester, ethyl butanoate, let's draw the structural formula for this. So structural formula means that I draw all of the lines, and I'm going to show all of the bonds. Okay, so now we are on page number 74, just in case you're wondering where we are, right? Page 74. So I named this branch first, and I have butane, which means 4 carbons, and then that F means 2. So this basically means I have a 2-carbon branch on the 4-carbon chain, and then the OATE tells me that this is an ester, and the ester functional group is the carbon-oxygen double bond O, and then I've got those R's and those R's. So this will be the ethyl part, and then that part over here is going to be the butanoate part. So then 1, 2, 3, 4. Okay, so that's our butane structure. Now I'm adding the functional group OATE. So here's our functional group, the carbon-oxygen double bond with the O, right? That's the ester. And now the ethyl part is the branch. The branch comes off of that oxygen. So F means 2 carbons, so 2-carbon branch. And then last but not least, so there's our skeleton structure. Every carbon gets 4 bonds around it, and you fill in the hydrogens. So I have an H. Let me erase because I got that weird line again that sometimes gets. H here. There we go. We needed 2 more on this carbon. That carbon's all set with 4. Oxygen's got it 2. Oxygen's got 2. Carbon needs 4. That one needs 2 more. And this one needs 3. Okay, so now I need to determine the gram formula mass. Well, I think this is a really good review of how to calculate gram formula mass. First, I need to figure out how many of each element there are. So let's get our molecular formula going. I have 1, 2, 3, 4, 5, 6. 6 carbons, C6. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And I have 2 oxygens. All right, so that's the molecular formula. Now I need to just figure out the gram formula mass, which is the mass of the formula in grams. And I'm going to use my periodic table because that's the only place I'm going to find masses of elements. And so I'm going to multiply 6 times the mass of carbon, 12 times the mass of hydrogen, and 2 times the mass of oxygen. So let's go forth and we'll go ahead and do that. I have 6 carbons. Each carbon has a mass of 12, so 6 times the mass of carbon. Where did the 12 come from? I used the rounded atomic mass from the periodic table. Now I need to add the next element's mass. I have 12 hydrogens, each hydrogen with a mass of 1. And now I'm going to add the mass of the oxygen. I have 2 oxygens. Each oxygen has a mass of 16. So then I do 6 times 12 plus 12 times 1 plus 2 times 16. And I add those all up and I get 116 grams. And what does that mean? Grams per mole. So that means 1 mole of ethyl butanoate is going to be equal to 116 grams. And just in case you were wondering, this is the pineapple flavor. Pineapple. Okay, there's our answer, 116 grams per mole. Okay, what can we classify this compound as? First, find something that looks different than all the carbons and hydrogens. So this. Then I go to table R and I find which one on table R has this. So I need something with 2 oxygens. So I am not going to do the amine because that's got a nitrogen in there. I don't even see any nitrogen in there. Organic acid has 2 oxygens. An ester has 2 oxygens. And aldehyde only has 1 oxygen. Okay, so now I've narrowed down my choices just by looking at the fact that there's 2 oxygens and no nitrogens. So it's either an ester or an acid. So the ester would have some other chain after that oxygen with carbons, right? An R group. So it's not going to be an ester. This is going to be an organic acid, our COOH, right? COOH, right? There's our code. So butanal and butanone have different chemical and physical properties, primarily because of their different functional groups. Okay, so a functional group gives physical and chemical properties, right? All organic acids are going to have some similar, not the same, similar chemical and physical properties. Same thing about esters. All esters are going to have some similar physical and chemical properties, right? They're all going to be very fragrant. They have the same number of carbon atoms because these are both bute, so that obviously cannot be it. Okay. And then there's our answers, which you already knew because it was in your notes. So now we're going to talk about our first organic chemical reaction. And we'll spend more time on organic chemical reactions when we do our organic reactions unit. But for now, let's talk about where do these esters come from? So esters are formed by the reaction between an organic acid and an alcohol. So our organic acid functional group and our alcohol functional group, they're going to combine together, and then in a reaction called esterification. Notice that the prefix is ester. So if you're forming an ester, the reaction is called esterification. So you have an acid and an alcohol makes an ester and water. And so since we have this water formed, this is going to be a dehydration synthesis, right? Because we're losing water. So here I have my acid, COOH, and my alcohol with the OH functional group. And now we're joining the two together and we're losing the water. So where are we losing the water from? We're losing an H and OH, right? And then now we're just joining R to there, right? So that's basically what's happening. So here we have our acid. So this happens to be acetic acid, which because the acetate, which is the two carbons, are ethanoic acid. Let's just write that down underneath there, right? Write down because we're not going to be focusing on the acetic part. So I hate that weird line thing. All right, let me erase that so I can make this look a little bit better. Okay. Alrighty. And I want to make sure that we're being consistent with New York. So we're going to call this ethanoic acid. So ethanoic acid, and now I have an alcohol, OH, with one carbon. So that's why that's methanol, OL. And now we're going to name our, so this is where those two are going to join up together, right? We're going to lose the H and the OH. So now let's take a look at how we go ahead and do this, right? So we are going to lose this H and the OH, and now then this part gets added to that part over there. So let's give this one a name. So we have ethanoic acid because I have two carbons and then oic acid. I have a one carbon alcohol, so it gets the OL ending. And now I'm going to name my branch first. One carbon branch is methyl. And now I count the carbons, two. So ethane, OATE. And then again, this could be acetic acid. All right, so on the structural formula in your answer booklet, circle the acid functional group only. So where is the acid functional group? So I got a whole bunch of stuff. So this is, a Regents exam question, short answer question. Where's the acid functional group? So I am going to look at my table R and I'm going to say, okay, there's the acid on table R. Which one looks like the acid on table R? So that's going to be this one. So I'm going to circle the acid functional group. Right? Now I've done 64. So now we're going to write oh my goodness, you get this weird thing in the question and you don't know how to do it. So if you don't like that IUPAC and it kind of makes you not sure what you're supposed to do, just try that question without it. Write a name for the reactant represented by its structural formula in this equation. Okay, so IUPAC just stands for Formal Naming System, International Union of Physics and Applied Chemistry. So for the reactant, where are the reactants? Where are the products? The reactants are on this side. So I'm naming this reactant. represented by its structural formula. Is X a structural formula? No. So then that's not what I'm drawing, right? I need to just give this a name. So then I'm going to mimic table R. It looks like you count the number of carbons and add the ending oic acid. So I've got 2 carbons. So this is ethane. Drop the E. Oops. And add oic acid. Ethanoic acid. So now in the space in our answer booklet, which we're just doing on our screen, we're going to draw the structural formula for the alcohol represented by X. Oh no. Couple different strategies for this question. I know that every chemical reaction, there has to be the law of conservation of mass. There has to be the same number of each element on both sides. So let's start by looking at what do I have on the left side, what do I have on the right side. I've got 2 carbons. I have 1, 2, 3, 4 hydrogens. I have 2 oxygens. And I have X. I know it's an alcohol. So I know I'm going to have an OH. And I know I'm going to have some number of carbons. It's just a matter of how many carbons. So then now I have 1, 2, 3, 4, 5 carbons. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. I have 2 oxygens. Oops, 3 oxygens. I'm sorry, I have 12 hydrogens over there. Okay, so now I have to figure out which one this is going to be. How many carbons do I have different? 3. So I need an alcohol with 3 carbons. Okay, so then that's going to help me with the carbons, figuring out the carbons. I need 3 carbons. So my carbons will equal 3. And so what else do I have? I have 2 oxygens and I have 3 oxygens. So how many oxygens do I need on this side? I need 1 oxygen. So oxygen is going to equal 1. So I have an oxygen, and I know it's going to be an alcohol, so I'm going to look on table R, and alcohol has an OH. And now if I make sure, there's my skeleton, should I now have the right number of missing hydrogens? So I should have the right number of missing hydrogens. Yes, I do. Okay. So I'll just go through here. And there we go. All right. The product of a reaction between an alcohol and an acid. So between an alcohol and an acid is our ester, right? Because I need to combine those, and they both have oxygens. So I need to end up with something with 2 oxygens because they both have oxygens. 1 oxygen, 1 oxygen, 1 oxygen. Ester. So now we're going to draw and name each substance for the balanced esterification reaction that produces propyl butanoate. And you're probably not going to be asked to do this on the Regents exam. So let's take a look and see what we have here. So I need to form propyl butanoate. So that means I have a 3-carbon branch on a 4-carbon chain with the ester functional group. So I have a 4-carbon chain. So 1, 2, 3, 4. And now I have the 3-carbon branch. I have my ester functional group, and then a 3-carbon branch. 1, 2, 3. And so now I'm going to make sure I have all of my hydrogens. Oops, get that one on the end. Okay, so now I have an acid and I need an alcohol. So this part over here comes from the alcohol. I'll just do ALC for short. This part over here comes from the acid. So I'll start with the acid. So I know I need this. And then OH. Oh, let me erase this. It's too messy. Can't stand it. Okay. Go back. Okay. Go back to pen. So then I've got my, this one's not so much better, but I've got, there we go. And now I have my OH. And now I've got, this part comes from the alcohol. So then I'm going to have, there's that OH, and then with that carbon, 3-carbon chain. And then there I have it, right? If I start with the end, it helps me work backwards to the beginning. And again, this would be definitely something honors level, and you would not necessarily have that on the Regents exam. On the Regents exam, you might be asked to find the missing piece. That's pretty much it. And then the rest of this is filled in your notes. Okay, so that wraps up our esters, and we'll spend more time on the esterification reaction in our esterification notes when we talk about more about organic reactions. All right, so our next set of lessons, our next one, we're going to talk about the last 2 compounds on table R, which is our nitrogen-containing compounds, and then that will wrap up our classification. Then we'll move on to organic reactions.